I would like to thank you for this insightful session and take this session forward. The applications of AI are often discussed in context of its transformative abilities to various industries. Its impact on education is empowering for both the educators and learners that further creates inclusion opportunities for everyone. Dr. Scott Klemmer's talk today will focus on AI's application in education from the perspective of consumer demand anticipation, improved delivery management, and preference-based browsing. Dr. Klemmer is a professor of cognitive science and computer science at University of California, San Diego, where he co-founded the Design Lab. He has previously served as associate professor of computer science at Stanford. He advises universities to design their programs globally. Dr. Klemmer, over to you.
Hi there. Good morning.
Good morning, Dr. Klemmer.
It's so great to be here, and it's a real honor to follow Dr. Gupta this morning. It was interesting to hear a talk about learning from a computer perspective, and I'm actually going to talk a lot about the many of the same topics of federated learning and other things, but where the learning agents are humans. And so I'd like to share my screen here, and can you all see the slides? Did that.
Not yet, Dr. Klemmer.
Okay, here we go. And did that work?
Yes, now we can see them.
Wonderful. Thank you so much. And actually, exactly as Dr. Gupta was talking about at the end, where um, in terms of providing AI support for healthcare, one of the I think I've actually worked a bit in that area, and I think one of the most interesting things in terms of the human facing side, which is where what I've looked at is that doctors as experts have they know a whole lot, and so having a computer simply tell a doctor what to do is fraught for a lot of reasons. And in my work on dynamic procedure aids with anesthesiologists at Stanford, they had this wonderful insight of using the phrase "consider" when offering suggestions. And we have a few papers on dynamic procedure aids that you can find on my website. I have the URL at the end. And so, yeah, right. So I'm going to talk a little bit about federated learning, and actually, I'm going to use some nice AI metaphors. So this is really great. Um, and what I wanted to start out with today is I'd like to talk about creative thinking from a human-centered perspective in terms of the AI analogy of simulated annealing. And I gave a talk a few years ago, and I asked friends of mine on Facebook, what's an example of something that you've prototyped in your own life? I do a lot of research on user interface prototyping tools, and I was speaking to a large group in downtown San Diego, and I wanted to convey that prototyping is something that's used not just in the software industry, but in all aspects of life. And I think, given the Geo Institute's really, I think, pretty broad and amazing mission, um, I hope that you'll be able to use human-centered thinking directly in the technology context, but also in a much broader context. And I wanted to share with you today some of the things that people came up with. And so you see a lot of things that you might expect, such as somebody used Lego bricks to prototype a mobile phone holder. Eric Sond, the computer vision researcher, gave an example of adding an extension to his house and making a small prototype of that. I actually installed an air conditioner recently and made a cardboard mock-up so that I cut things the right size and was able to reason through what made sense. But a lot of the ones that I think are most interesting are so on the top right, you see Maria, who prototype, will the TV fit on the wall next to the plant? And even more broadly, Mariana says, well, I prototyped, I joined Big Sisters to prototype parenthood. And I prototyped living with my boyfriend for 3 months in Berlin before we moved in together. And interestingly, I think, well, and actually in terms of a really permanent one here, we've got Alexandra says, I made a temporary tattoo as a prototype before I got the real one. And all of these prototypes are examples of how somebody uses objects to be able to reason through multivariate, thorny problems. That one thing that shows up in all kinds of prototyping is that you don't know uh, what you don't. Often the things that don't work are things that you never even thought to consider as an axis. And sometimes when you're like, okay, how exactly am I going to do this thing? Maria's trying to figure out where the TV goes on the wall. And Meenal created a standing desk. She's an entrepreneur who works from home. And she creates a standing desk and realized she hates having a standing desk. And I think that making a prototype and realizing it's not what you want is so much faster than making the real thing. And for this group, I wanted to talk about creative thinking as simulated annealing, and this is work with my PhD student Trisha Noon, who's a cognitive science PhD student. And I think what's really interesting is that early on in any creative process, uh, it's important to be able to think really broadly. And in simulated annealing terms, I'm guessing for an AI audience, much of this will be familiar, but just in case, simulated annealing is an analogy to physical annealing, where a blacksmith will bang metal, and it's easier to manipulate the metal when the metal is hot. And as the metal cools or anneals, it becomes stiffer. And so in the pliable stage of early creative thought, you want to bounce around a lot. And then in the later stage, you want to be able to refine things more carefully. And one thing that shocks me again and again and again and again, and it's especially embarrassing because this is true when I do things myself, is that most people in most situations massively underinvest in the high entropy phase of creative thinking. And I believe that the reason that we do this is a cognitive bias where we assume that we're basically on the right track. And so we say, well, bouncing around and trying just a bunch of different stuff is just a waste of time. And you see an example of people assuming that the design space is much narrower than it actually is in some work that Stephen Dow and I did, where we asked people to prototype a device to protect an egg from a fall. So we threw people's physical devices out a window and wanted to see if they would hold up. And what's really remarkable here is that, well, I'll just play the video.
No, I don't know. For some reason, this seems to be the only idea. There needs to be a platform, and then as good a cushion as possible with the materials. I don't see any other way.
I'm not a very good outside the box thinker, so I kind of just had one idea, and I was going to try and make it work.
I kind of went with the whole parachute idea and what I had from the beginning. So
this is the best approach for such a design.
And what I love about this example is that everybody's got completely different things, and each of these participants didn't see what each other did, and so each of them is convinced that whatever path they're on, it has to be that way. And I'm embarrassed to say that I've often felt this way myself, where I'm doing a design project and I'm like, well, of course it has to be this way, but often it doesn't. And I wanted to give an example to bring it back into the technology world. which is in terms of, this idea of prototyping spans not just if you want to find a way to hold your telephone or, build an extension on your house, or even do personal things like make big life changes. Um, in the computing world, here's an example of my former student Mike. And soon after the first iPhone came out, Mike and his friend Kevin were thinking about how they might create a photo sharing application. And so they created this system called Bourbon. And the way that Bourbon worked is Mike and Kevin knew that you would only ever be willing to share photos with your close friends. And so you had a way of sharing things with close friends where you would check in at a spot, and that way your close friends would know what you were up to. And Bourbon just completely flopped. Like, it never really went anywhere. And one thing that I think is interesting when you have something that doesn't work is you have to ask the question, at what scale, at what level of entropy do we want to be able to make the change? Is it everything would have been great if I just changed the fonts? Or is it, mobile phones are stupid, I should just do something else with my life? Or is it, somewhere in between, for that vast space of in between? And so Mike and Kevin decided to have a second whack at it. And here you see some early prototypes of the application Instagram that I guess many of you are familiar with. And what's interesting is that many of the things that Mike and Kevin knew to be true were things that their subsequent prototype accidentally or intentionally abandoned, and that enabled them to be much more successful. And I'll tell just one very short story about this today, which is that Mike was an undergraduate researcher with me, a master's student with me. He TA'd for me. We're really close. He's one of the most talented people I've ever met. And Mike knew that you would only ever be willing to share photos with your close friends, and this would have been I don't know, 2009 or so. And but Mike was also, because he was a great designer, when they first built Instagram, Mike was like, well, we're only going to have a couple dozen people at first. And so the auth model of being able to limit who you share with is something that will become important as we scale. And so for the first version, uh, anybody can follow anybody. And that was a choice made for minimum viable product purposes, to be able to get something out and try it purposes. Even though Mike knew that later they'd have to go back in and add something else. And what's extraordinary is that about the 12th user of Instagram was this fellow in Hawaii who takes beautiful pictures of sunsets. And all of a sudden, the other 11 people who don't all know him are all following this guy. And Mike and Kevin are like, wait a minute, this is different than we thought it was. And I love that example because it shows how releasing something before you're ready is a great way to figure out not just the things that you need to figure out, but of having the assumptions that you have be completely violated and enabling you to pivot more efficiently. And I think that what design does, in my opinion, is that it creates postcards from the future. That what Mike and Kevin did by releasing Instagram with a few people is they got to see a world in which people could easily share photos, and then they realized what that needed to be. And so when you're prototyping, you're time traveling into a future, and then you can send a postcard back to yourself in the present to be able to learn more about what that future might be. And so, given today's topic, what I wanted to talk a little bit about was thinking about scaling open-ended work. And my understanding is that two of the Geo Institute's first emphases are AI and data science. And when I was at Stanford in 2010, and we started putting together massive open online courses, the three of the ones that were a very early focus were AI, databases with Jennifer Whittam, and then my HCI course, and with the view that those are really three of the areas that are, I think, Andrew Ng talked to me about these once as a new computer science, that it's different than the stuff that he and I learned when we were in school, and have become, I think, increasingly relevant. And so I wanted to talk about our work here, both to encourage the Geo Institute to think about human-centered computing processes as it expands and grows and fleshes out its mission and content, and then also in terms of thinking about. So I think human-centered computing design can be both a content area and also offer a methodology, and I think these are especially relevant for the world that we're all in now, where I think nearly all of us are over Zoom. So we thought about trying to scale the design studio to the globe. Um, the first classes that Stanford put out in terms of the massive open online courses were things that a computer could check the result to. That we could write an auto grader to say, does your SQL query produce the right result? That's a little bit more difficult if you're going to ask, does your social computing prototype produce a successful startup? We don't yet have an auto grader for that. And what I think is really interesting is that, and appropriately to the end of Dr. Gupta's talk about the nature of truth, is that there are some things in life that are clear contextual, or that are clear objective truth. 3 + 4 = 7. There's 16 ounces in a pound. The car's going this fast. Things work this way. And then, at the other end of the spectrum, there are things that are just individual taste. And what I want to emphasize is that this isn't a binary things living in one category or the other. I think people often make that mistake. And for me, most of the interesting stuff in life is stuff that lives in a middle ground, something like measuring the quality of a literary work. Not all books are equally good. It's more reasonable to argue that this particular book should win the Booker Prize than that one. The first time I traveled to India, I read Salman Rushdie's Midnight Children when I first arrived, and an individual may or may not like that book. I loved it. It's a reasonable candidate for an award like the Booker Prize, in a way that most of the stuff that most of us write is very much not. And so even if there isn't a single individual clear answer, there are things that are more and less reasonable. And I think that kind of contextual truth is extremely interesting. So, we put an HCI class online, and in terms of things that we've done with large scale learning that leverage both forms of crowdsourcing and also in places some rudimentary AI techniques. One of the things that we did to be able to handle this contextual truth challenge was peer grading. And I can remember when Daphne Kohler proposed to me to put my class online along with her the AI class and the database class. Is I was like, yeah, Daphne, I mean, I can put the lectures online easy. We've been recording those already, but how do you do projects online? It seems, you'd have to do like global scale peer review. And Daphne's like, great, let's do it. And so she and I inked out, along with my PhD student, Chin Michael Carney, who's a BITS Polanyi alum and now a faculty member at Carnegie Mellon. We inked out on my whiteboard one March a peer review system for people to review each other's design work. And on online platforms today, nearly all of the major online platforms use some variant of what we came up with. And it works actually pretty darn well. And one thing that was really interesting for me was being able to take something that was on my whiteboard in March and then 3 months later have a something that was used by many thousands of people. Um, and I was really struck. I've been really interested as some of the large technology companies have been testifying in front of the U.S. Congress recently. And one mantra that's come, I think, appropriately under particular scrutiny is Facebook CEO Mark Zuckerberg's early slogan for Facebook of "Move fast and break things." And that what I think was interesting about that is that a lot of American politicians look at that, a lot of Americans look at that, and they're like, "That's just completely crazy." And what I think is interesting, and Zuckerberg's response was, "Well, look, when I started Facebook in my dorm room, I had no idea that a decade from now, uh, my biggest worry in life would be Russian hackers." And I think that's an honest thing to say. It's also dissembling, um, and what it points to for me is that, you know, when you're making a prototype that lives entirely in your dorm room, move fast and break things is great. When I make a prototype for how to hold up an air conditioner out of cardboard, uh, if I tear apart the cardboard one, or it breaks, or it's the wrong size, or whatever, who cares? If one were to make that a product that half the planet used, that becomes no longer appropriate. And so, um, what I think is really, for me, the entire crux of a prototyping mindset is the idea of um, when designers create something, uh, it often looks to the outside world like the designer is creating an artifact. When I was in graphic design at RISD, the Rhode Island School of Design, if you walked into a studio, what you would see is rows of students hunched over their work, and it would look like they're making objects. It would look like they're making artifacts. And what I think is really interesting is that what designers are actually doing when they are making prototypes is they're making questions. And these questions are a form of productive doubt. We don't know what the future holds, but we also don't just throw up our hands and give up. And the art of good design is about being able to uh, ask good questions, and also to be able to guard against uh, cooling too quickly with simulated annealing. And one thing that we know from cognitive science is that there's a huge risk of confirmation bias. That once we have a belief in our heads, we pay more attention to evidence that supports that view than we do evidence that cuts against that view. And there's a technique that actually my collaborator on the medical research that I mentioned at the beginning, Stu Card, taught me, called alternative competing hypotheses. And in this framework, uh, one enumerates multiple different possibilities and then weighs the evidence against those multiple different possibilities. And so by producing multiple alternative competing hypotheses, and in our work, we've looked at this as by producing multiple prototypes, what we do is that can help guard against confirmation bias. And I think, given the momentum of cooling too early from a simulated annealing perspective, there's a corny joke I always tell on the first day of my class, which is, how many designers does it take to change a light bulb? And the designer's response is, you don't need a light bulb, you need a new illumination experience. And what I like about this is, I gave the keynote for the Collective Intelligence conference a few years ago, and I told this joke there. And Jeff Nickerson, the creativity researcher who was trained originally in, who has a background in architecture, he said this really wonderful thing to me. He said, the "you need a new lighting experience" is negotiating the valuation criteria. That one of the coolest things about creative work is that you're not just arguing about what the solution is, you're arguing about what the yardstick is. And that's the switch from changing a light bulb to the illumination experience is it's pushing back and saying, let's broaden our evaluation criteria. And I think that's a wonderful opportunity for uh, the Geo Institute. And one thing that we've done a lot of work on is that when you put together large scale peer feedback, and I've decided not to talk about the particular systems today and more the broad way that we think about this research. But I'll put up my website at the end, which has a link to all of our papers. And I spent some time as I spent spring break one year as a distinguished visitor in the Harvard Graduate School of Education, and I got to spend some time with the professor there, Nancy Summers, who's done a lot of work on writing feedback. And what I love about Professor Summers' work is that many of us, even those of us that are experts in a domain, are lousy at providing feedback. And the reason is that, one might be taught to do a particular, write in a certain, I might be taught to write philosophy, but almost none of us are taught how to best provide feedback to others. And in an increasingly collaborative world, or at least hopefully collaborative world, this I think is a huge problem. And it's something that we've capitalized a lot in our research, is helping use techniques for providing productive feedback to be able to scale globally new forms of education. And I think this is a big opportunity for the Geo Institute in particular, is that if all of us schools in the United States aren't giving enough attention to providing feedback, this is an area where it could be a huge contribution to do this better. And in particular, one of the most common errors that people make with feedback is to offer something that is overly vague. And I have an example on the slide here of a professor writing awkward about writing. And what's difficult about that is that in their head, the professor has an idea about what the problem is, but all they communicate is awkward. And so the recipient of that feedback is wondering, is it the grammar? Is it the overall argument? There's a lot of possibilities there. And so good feedback, Nancy Summers teaches us, is specific, actionable, and justified. And we've built frameworks that help scale that style of feedback into our systems, like Critique Kit, which is a platform for providing better feedback on creative work. And I think one reason that this works is that most errors that people make are variations on a theme. And one of the classic insights of human-computer interaction from Jacob Nielsen is that recognizing errors is a much easier cognitive task than being able to articulate what the issue is. That being able to recognize an instance of something is easier than generating an instance of something. And I think about this in long tail terms, that in almost any domain, whether you're talking about painting or algebra or user interface design or anything else in the world, tennis, there are a few mistakes that are extremely common. Nearly everybody makes error X. And then there's going to be another set of confusions or errors that are somewhat common. And then there's going to be a long tail of confusions that only a few people have. And in terms of authoring curricula, especially large scale and or online curricula, with I use this long tail diagram as a design framework, because the really common stuff, if I was thinking about teaching physics, the misunderstandings that nearly everybody has, those really common insights, are something that we should just put huge resources into pre-producing very high quality learning materials. Those might be teachable agents like Ken Kadinger and others create. It might be, a movie about a particular technique, whatever. It's worth putting in the resources because you'll amortize that. And then in the middle, you'll have stuff that you might pre-produce and becomes kind of a choose your own adventure, where if this comes up for you, well, we'll show you this choice. And that's where a lot of my group's research is focused. And then on the rare side, that's the stuff that you couldn't anticipate in advance. And so it's necessary to be able, that's where I think the power of crowdsourcing and of peer review comes in, is that you say, well, heck, we couldn't have anticipated that. And so by having a planet-wide community, we could all help each other learn. And so I wanted to show just one example of one of our systems before I close, which is that here's our critique kit system that Tricia Noon and Ailey Fraser led the research on. And what's really cool about this is you can see two alternative designs for a user interface prototype. And on the right-hand side, you see the critique kit panel. And what this does is teaching assistants, when they review work, our system will save the critique they offer and enable those insights to be reused for later work, which is relatively simple and also completely transformative. Also, you can see in the top right here is if I offer feedback on this user interface on the left, the critique kit system will evaluate whether that insight is specific, actionable, and justified, the three goals of feedback from Professor Summers. And we have some very simple AI under the hood that checks whether things are specific, actionable, and justified. What's under the hood there is not at all the point, and the user themselves can check or uncheck and self-audit what they're putting together. And I think that being able to provide some scaffolding is extremely powerful for open-ended creative tasks. All right, so I know that I've got about 4 or 5 minutes left here, and I'm really curious to stop at this moment, and I'll stop my screen sharing, and I would love to hear whatever questions you have. And I believe you're muted.
I'm sorry. Thank you so much. Thank you, Dr. Klemmer, for this terrific talk. It was a very insightful session. Just had a few questions from the audience. One of them being on the lines of peer review in education. So, how do we? So, one of the audience gave an example of how in UK AI was used to determine students' exam grading, and most students could not do very well. So how do we mitigate all of these issues?
Yeah, I haven't read all of the details on the recent mess in the UK around auto-generating exam grades. From what I've read, I think that particular example was just a well-intentioned idea that was stupid. And actually, all right, I'll answer that one, which is that what's remarkable about that particular example is that it was rolled out at massive scale, as far as I can tell, without ever trying it with anybody first. And my hunch is that if they had, it seems to be a stupid idea, and I'm not totally familiar with it. And if they had, and all of us, even really smart people, regularly come up with stupid ideas, and you can't just roll things out without trying it first, assuming it's a good idea. And my hunch is that if they had tried it with somebody first, they very quickly would have realized that this was not what they should do. And so I think that the solution on that one is actually quite simple, which is that a rapid prototype is a powerful antidote to believing our stupid ideas are brilliant, as I've regularly learned myself.
Thank you, Dr. Klemmer. Would you like to comment on how startups can kind of focus on exploring AI for education, for student recruitment, or for curriculum planning and things like that?
Absolutely, and a number of my former students have done startups. For example, one in India is Neil Patel, based in Ahmedabad, has a startup called Awas Day, which scales feedback for, in particular, farmers through a voice-based system. And what I've seen with startups is that, in fact, I'm thinking about, there was a group of my former students founded an AI startup for doing automated design feedback. And what I saw was that they were such perfectionists and were such convinced of their idea that they built the underlying, algorithms and infrastructure for several years before really rolling it out. And then they ran out of money and had to fold up. And at the moment that the startup closed shop, they figured out what they actually should have done.
Thank you, Dr.
And
Klemmer.
so I think that's the error mode to avoid.
Thank you so much, Dr. Klemmer. The audience actually had a lot of questions, but we are kind of we have a paucity of time. We will send some of the questions over to you on email.
Oh, please do. Yeah, I think that
thank you.
what all of you are doing is amazing, and I want to keep you on time, and so best of luck, and I look forward to hearing what you all come up with.
Thank you so much, Dr. Klemmer. This was a really interesting talk on cognitive sciences and AI and how they are impacting education.